Okay, so we'll do this test here. Write it down along with me. Test-2.3B, I think. Okay. Question B, 3, 4, and 5. This we'll find on textbook page 38, I believe. Yes, 38. So write the portion along with me. Go to page 38 of your textbook, and let's start with B3. Okay, let me read the question for us. Obtain all the other zeros of 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5 if two of its zeros are root over 5 by 3 and minus root over 5 by 3. So here, let us assume from the first goal or first step, let p of x be the given polynomial there. 3x squared. Okay, so sorry, 3x to the power 4. 3x to the power 4 plus 6x cubed minus 2x squared. Okay, minus 10x and minus 5. So let us denote this by p of x, the given one. Now, here, given in the question, since root over 5 by 3 and minus root over 5 by 3 are, okay, the two zeros given, two zeros, okay, of p of x given in the question. Therefore, we can assume, here you see, let me explain this. The zeros we have done for quadratic equation, right? So while we solve a quadratic equation by factorization, I'm just trying to give you a picture of analogy, okay, between this meaning of zeros. So here, quadratic equation has only two zeros, and suppose we factorize a particular quadratic equation, then it appears as in the factorized form as x minus 5x plus 3 equal to 0. That's called the factorized form. So either we write like this, x minus 5 equal to 0. That gives you x equal to plus 5, or x plus 3 equal to 0. We remember doing this, right? X equal to plus 3 go right side, minus 3. So the two zeros are plus 5 and minus 3. So if the zeros of this quadratic equation are plus 5 and minus 3, in the factorized form is the opposite signs here. 0 is plus 5 means in the factorized form x minus and whatever is the 0. Similarly, the other one, this 0 is minus 3 means x minus and whatever is 0, we put x minus and whatever is 0. So we need a second bracket here. So we write in the factorized form as x minus whatever is the 0. Similarly, if these are the two zeros of this quadranormal, I think, because the highest its degree is 4, right? If its highest power is cube here, x cubed, then it's called cubic polynomial. If its highest power is 2, then it's called a quadratic polynomial, but highest power is 4. So this polynomial here will have 4 zeros. Quadratic, if the degree of any polynomial is 2 quadratic, then it has 2 zeros like that. If it is cubed, then it has 3 zeros normally, right? So here, just like that analogy, x minus the first 0 root over 5 by 3, right, in the factorized form, and x minus whatever is here, again minus root over 5 by 3, minus x minus whatever plus root 5 by 3, x minus root 5 by 3. So in between these two double signs, we put this bracket and close this. So these are the two factors. In other words, if root 5 by 3 and minus root 5 by 3 are the two zeros of p of x, then x minus first 0 and x minus second 0 are two factors of p of x. So we have got that one. So that is okay. So that is the one. Now therefore, when we put these two factors together and factorize them, we get here x minus root over 5 by 3, and here x minus and minus plus root 5 by 3, okay, will be equal to, let's do this two combined. These two combined can be one factor, therefore there are two factors. If you combine these two, it can become one factor, right? So here a minus b into a plus b, because this is the same xx, root 5 by 3, root 5 by 3, so a b. So a minus b into a plus b we know is a square minus b square. So we got this one. We know this formula, right? Very common formula. A plus b into a minus b is a square minus b square. So here a minus b into a plus b. A plus b into a minus b, or a minus b into a plus b, same, equal to a square minus b square. So a square x square, b square is root over 5 the whole thing square. So it gives us here x square minus root 5 square means root remove, root 3 square also 3 remove. So this is the factor that we obtain, factor of p of x that we obtain when we combine the two factors that we got from using its zeros, right? So we can write here, therefore this one here, these two combined, this one is also a factor, it's also a factor of p of x. Keep it like that. So let us now, since this is the combined, this is the main factor of these two combined, so we can consider this as the main factor. Okay, so this factor here, let it divide p of x. So on dividing p of x, okay, on dividing p of x by this new factor by x square minus 5 by 3. Okay, what do we get? Let's see. So we know that if x square minus 5 by 3 is a factor of p of x, factor of this one, and when we divide this p of x by this factor, whatever we obtained as a quotient will also be another factor, right? So we're trying to find all the factors of p of x so that we can answer our question, find all the other remaining zeros. So when we divide this, we know the normal division process. So let's write down here is also okay. So here we divide. Now write down this one. 3x to the power 4 plus 6x squared minus 2x squared minus 10x minus 5. Let me check once more. 3x squared plus 6x cubed. 6x cubed minus 2x squared minus 10x minus 5, yes, divided by this new factor, combined factor that we got from here, x squared minus 5 by 3. So here we write x squared minus 5 by 3. I want to go slow with this. So we have learned the division in the previous test. So we can now divide this polynomial. For that, we take the highest degree term of the dividend. Inside is dividend, outside is divisor. Highest degree means the term having the highest power of x. Power of x here is 1, no x here, 1, 2, 3. Power here is 4, highest. So the term having the highest power of x is this one. That is called the highest degree term. So we'll divide that. You can write down on your graph. Highest degree term of dividend divided by the highest degree term of the divisor. Here the highest degree term means the term having the highest power of x is x squared. There is no x here, so highest degree term here is x squared. So this x squared and 4 minus 2 means 2 less. So 3x squared we obtain. That we write in the quotient, the space for quotient So now we'll multiply this to both of these. 3 1s are 3. Then x squared into x squared means the power will be the 2 plus 2, so the power is x to the power 4. And plus into minus is minus. So let's do that first. So write this on your graph. I'm going to rub out, okay, so that I'll have space for myself. So here. Next is this multiply this. So 3x squared right on your graph into minus 5 by 3. Let's try. This 3 into means here 3 cancel. Plus into minus, minus. 5 into x squared. 5. Oh, sorry. Not here, sorry. Here, down. So plus into minus, minus. X squared into 5 is 5x squared. So we're going to get, you can write this on the graph. So minus 5x squared will match with this as a like term, x squared. So we write in that place minus 5x squared. Right. Then we'll put a long line here. Since this has multiplied this and got this, this 2 multiply, we got this, as you can see here. You write these things on your graph so it'll be clear about it. Now before we find the remainder, we know that the lower signs of the lower terms should be changed. So the lower upper terms are this, lower terms are this. So lower term minus 5x squared will become plus 5x squared. Plus, no sign means plus 3x to the power 4 will become minus. So minus 3x to the power 4 plus 3x to the power 4 cancelled. Here is plus 5, here minus 2. No more minus, so put the bigger one plus 5 up and smaller one minus 2 down, because that's how we do. So when it's plus minus, we subtract. So 5 minus 2 is 3. Bigger number is 5, its sign is plus, means the answer here 3 will also have plus sign. You can write these things on your graph. So this is plus 5x squared minus 2x squared is plus 3x squared. I got that remainder. Then we write here, in front there is one thing here. So plus, right? Because there's no sign means plus, and this one right in its own place, 6x cubed. Then bring down this one, minus 10x. This one, minus 5. Okay, so once we're done with that, we continue to divide. How long? Till this highest term of the new dividend becomes lower than the highest degree term here. Highest degree term x squared still here cube, so it's still higher. So till it becomes lower, we continue. So let us do that. So for that, we take the highest degree term of the new dividend here. Highest degree is the term having the highest power of x. Highest power of x is here cube square. So this highest power, the term having this one is 6, whole thing is 6x cubed. So write that on your graph. And we divide it by the highest degree term of divisor. So when you cancel this, 3 minus 2 is 1. So there will be here 1 left, means no need to write 6x. You can write this on your graph. So when we divide this highest degree term of new dividend by highest degree term of divisor, we got whatever we got is we write here in the question space minus 6x. Then we multiply that to both of these. So minus into plus is minus. Okay, so here, oh, this is not minus 6, but this is plus 6. When we divide the highest degree term of new dividend by highest degree term of the divisor, we got plus root 6. Plus 6x, sorry, plus 6x. So plus into plus is plus. 6 ones are 6. X to the power 1. X to the power 2 means 2 plus 1 power x cubed. Then let us do the next one. Right, okay, as soon as I've this will multiply this. So 6x multiplied 2 minus 5 by 3. So 3 2s are 6. So you're left with plus and minus is minus. 2 5s are 10. X is what we get when we multiply this to the next term of the divisor. So minus 10x, search for the like term. Here, x, so right in the same space. Minus 10x. So we multiply this to this, we got minus 10x, we write it there. Since this has multiplied both the terms, all the terms rather, of the divisor, we stop and put a dash again. And before we do the remainder again, we change the sign. Plus becomes minus, minus becomes plus. So plus 10x, minus 10x, 0. Minus 6x cubed plus 6x cubed, 0. So we're left with here 3x squared. And here, minus 5. Right. Again, this power is still equal. X to the power 2 highest degree term of new dividend is still equal to highest degree term of divisor. So we have to continue dividing till it becomes lower. So as long as this one is higher or equal to the highest degree term of the divisor, we must continue dividing. So let us do that. So here we go and do highest degree term of the dividend divided by x squared here. So these two cancelled and we're going to get here plus 3 equal to plus 3. So we write here plus 3. So when we multiply 3 into x squared is 3x squared. Okay, 3x squared. And then plus and the minus is minus. Then multiply this to this next. So this 3 will multiply this minus 5 by 3. Up and down cancel, we're left with equal to minus 5. Write this on your graph. So we're going to write here minus 5. When we multiply this to this, whatever you got, minus 5, so we write it here matching the like term place. Then we subtract here, plus 3x squared becomes minus, minus becomes plus. So plus 5 minus 5, 0. 3x squared minus 3x squared, 0. So remainder is 0. You can stop. Write it down up to there. Now, having done that, now we can solve it now. So here, that is, now we're going to get here, that is, this quotient here, the one here, that is right, 3x squared plus 6x plus 3 is also a factor, is also a factor of p of x. So let us write down now all the factors of, now we don't need this, so I'm going to rub out. So write down here, therefore, or that is, whatever you like, that is the factors, that means all the factors taken into account, factors of p of x are, these two are the factors, but we combine them to get a more complex factor here, x squared minus 5 by 3. When we multiply this as factors, we got this. So this will represent both of these, so we can just take this alone. Are x squared minus 5 by 3, and the other main factor that we got now here, after when we divide p of x by this main factor, x squared minus 5 by x, whatever factor we got here, this one will be the remaining factor. So, and 3x squared, okay, plus 6x plus 3. Right, 3x squared plus 6x plus 3. So these are the two main factors of p of x that accounts for everything of p of x. So we can write here now. Now we can write here p, I think we can just go here, yes, p of x. P of x in the factorized form, let us write down, is simply this one here. 3x to the power 4 plus 6x to the power 3, 6x cubed rather, 2 minus 2x squared minus 10x minus 5. This is the p of x, and in its factorized form we can write it as these two multiplied. So here you can write x squared minus 5 by 3, its factors multiplied, 3x squared plus 6x plus 3. So all the factors of p of x multiplied is actually p of x. This one, when we multiply, we'll get this. We know this by common sense. So you can simplify this. So here we can write equal to, now just look here and understand, 5 by 3 we can also write it as root 5 by 3 whole thing square. Root 5 by 3 whole thing square. X squared minus root 5 by 3 whole thing square. And I put here a bracket. Let me explain that. Root 5 by 3 whole square. Root 5 by 3 whole square means Square and the root will cancel, so 5 by 3 left. So 5 by 3 can be written as, this 5 by 3 can be written in another form as root 5 by 3 when we put square. That's allowed. And then we can split this middle term because this is a quadratic polynomial. So plus into plus is plus 3 3s are 9. And then here, middle term is plus 6. So we have to get factors of 9. 3 3s are 9, for example, so that when we combine plus 3, exactly middle term, plus 6. Multiply, 3 3s are 9, plus 9. Multiply the splitted factors, we get the product of the first and the third term. 3 3s are 9, and the middle term. When we add, we get exactly the middle term. So this is the right factorization. You can write it on your graph. So we're going to split the middle term and solve this portion, simplify this portion. So let me write here 3x squared, and this 6 plus 6x is going to be split into plus 3x plus 3x is plus 6x plus 3. Then here you can see here a squared minus b squared is simply a plus b. B is root over 5 by 3 into a minus b. I'm applying the formula, okay? A minus b. So here minus b is root over 5 by 3. So I can write like that. Okay, or if you want to use second bracket, first bracket is also fine. Or second bracket, then you can use both as second bracket also. That's up to you. Given that we're using here second bracket if you want. So this portion here, a squared minus b squared, has been split into a plus b into a minus b. Now let's factorize this. Highest common factor of 3x squared, 3 and 3 is 3. X squared and x is highest common factor x, put bracket. And 3x into x is 3x squared plus 3x has gone outside, so what is left is 1. 3x into 1 is 3x. Then these two you combine. 3 and 3 highest common factor is 3. X is here but not here, so that's not a common factor, so you put bracket. 3 gone out, so x will be inside. Plus, so you just put there, plus into plus is plus. So 3 we know is 3 ones are 3. Then here is multiplied, so we have used up the second bracket and there's a break here plus. So to indicate multiply, we'll put here a second bracket into. Okay, then here x plus root 5 by 3. Then here x minus root 5 by 3. And here in these two terms the common factor is x plus 1, so you can write here x plus 1. Okay, x plus 1 and put a bracket. Then this has gone out, means inside will be 3x. And x plus 1 has gone outside, so inside will be this one left plus 3. Let's just do slowly. Now we have got this given polynomial p of x expressed in multiplication of its two factors, this and this, and then simplified to its factorized form. You can stop there once. Okay. Then we can write here. Now for n is 0. Okay. Since we know for n is 0, okay, p of x is always equal to 0. Let's separate this part. So p of x is always equal to 0. So in other words, that is p of x is this in its factorized form. So let us take this form. P of x be replaced by p of x on the left side, 0 on the right side, of equal sign on the left, be replaced by this simple factorized form of p of x. So you can write this one, x plus root 5 by 3 into x minus root 5 by 3 into, I can just wrap out this portion, I think. That's fine now. Into x plus 1 into 3x plus 3 will be, so this p of x has been replaced by the simple form of p of x, factorized form, equal to 0. Why? Because the question is asking us to find the remaining zeros. So you can follow me, just do that. Now, since it's completely factorized, we know we can find out the zeros. Therefore, either the first factor x, here you can see here, x plus root 5 by 3, this one into this equal to 0, means this should be equal to 0, or this should be equal to 0, or at least this should be equal to 0, or this factor should be equal to 0. Otherwise it cannot come out equal to 0. So we're assuming either this one will be equal to 0. So if it's this one, this factor is equal to 0, then our value is 0. 0 means x value will be equal to plus root 5 by 3, go right side, minus root over 5 by 3. So first 0. Plus 0, no need to put 0 now. So here, or the second factor, x minus root 5 by 3 will be equal to 0. So that gives you x value equal to minus root 5 by 3, go right side, then plus root 5 by 3, the second 0. Plus root 5 by 3. Or the third factor, x plus 1 will be equal to 0, which will be equal to x plus 1 shifted right side equal to minus 1. Third 0 is minus 1. And finally the fourth 0, or the last fourth factor, 3x plus 3, 3x plus 3 will be equal to 0. So 3x, shift this plus 3 to the right side, then minus 3. And x we're trying to find out, so x equal to minus 3, this one by 3 into, means it will come down when you shift the right side. So 3 ones are 3, 3 ones are 3. Minus 1 by 1 means simply minus 1. So the four zeros of this p of x here, 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5 has four zeros, and the four zeros are minus root 5 by 3, plus root 5 by 3, minus 1, and minus 1. Now the question has already given us, the two zeros. Go back to question, obtain all the zeros of this 3x to the power 4, etc. if two of its zeros are already plus root 5 by 3 and minus root 5 by 3 are given already in the question in the beginning. So these are already given. So the remaining are these two. So you write here, therefore, go back to question and saying obtain all other zeros. So the other zeros, or in other words, the of p of x are already given in question, these two, and these are the ones missing, and so minus 1 and same one, only minus 1. So this is your answer. We'll do the 4 or 5 in the next class. Okay.